working with fractions. Okay. So let's multiply. When we multiply fractions, it is recommended to simplify the fractions before we multiply them, if possible. Not just simplify each fraction by itself, but in a product, I'm also allowed to simplify across. Okay? So in this example of 8 over 15 multiplied by 27 over 30, yes, I can go ahead and multiply the top and multiply the bottom because that's the procedure, right? So let's write the procedure first. A over B multiplied by C over D is multiply the tops, A times C, multiply the bottom, the two numbers, factors in the denominator. Okay, that's the idea. But I would rather do this first. 8 and 15 do not have a common factor. What is a common factor? Is a number that both of them are divisible by. So 8 is only divisible by 2 as prime number. And 15 is divisible by 3 and 5 as prime number. Nothing in common. Now let's look here. 27 and 30. Do they have a common factor? 3. So I will do this. 27 divided by 3 and 30 divided by 3. If I divide the numerator by a number, I have to divide the denominator by the same number. If it's not working, then I can divide. I can simplify. So the new fraction now is, can anyone dictate?
8 over 15.
Multiplied by?
By 9.
Good. Now both fractions are fully simplified. Cannot be further simplified. Now I'm going to see if I can simplify across. Never top with top and bottom with bottom, but across. And yes, 8 and 10 have a common factor, which is, so I'll simplify 8 by 2, but at the same time I have to simplify 10 by 2. What do I get?
5.
Awesome. Now let's look at 9 and 15. Can I simplify 9 and 15 by anything? Is there a common factor there? Yes. So 9 divided by 3 is?
3.
And 15 divided by 3 is?
5.
Finally, can anyone tell me what is left at the top? Don't write anything yet. Just tell me what is left at the top.
4
Times?
times 3.
Awesome. And the bottom?
5.
Times?
Is the denominator.
But it's a multiplication.
25.
So when I multiply 4 and 3, I have to multiply 5 and 5. I cannot just say, okay, I'm not going to multiply the 5. Right? So what is the simplified form of this product?
It's 12 over 25.
Yes, no, agreed, disagreed. Anything?
Don't you have to simplify that one down too, though?
12 and 25 have nothing in common. 12 is divisible only by 2 and 3.
Yeah.
And 25 is only divisible by 5.
Okay, gotcha.
We only talk about prime numbers. Right? Okay. So now it's your turn. Ready?
Yeah.
So I'm going to make one up. 36 over 11 multiplied by 22 over 12. Now here's the idea. If you multiply the tops and multiply the bottoms, and you get a huge number at the top and a huge number at the bottom, then you're going to start and say, okay, what am I going to simplify by? Okay, are they prime numbers? Are they divisible by 2? Are they divisible by 3? So it's more difficult than if you take it step by step and you simplify before you finally write the answer. Right. Right. Also, I would have better, I think, is the 11 with the 22 because they're both divisible. But it's okay. It's not a mistake. How are we doing? How are we doing?
I'm terrible at math, so we'll see.
Okay. How are we doing?
Okay, I guess could have probably simplified this down more.
So you simplify that by,
This one probably should be,
yes, and then the other one by 3. Okay.
and then I got here,
Right. But 2 over 4 is?
that would be half.
Yes, exactly. So what do you think is the question? What do you think is the question?
I'm just.
Okay. How are we going? Okay. So you simplify by 12. Yes, and you simplify by 11. And 3 times 2 is?
6, sorry. It's close.
So what did you simplify by? Look at 11 and 22. And go.
I don't know why.
Okay. Well, I'm glad you're here. Yes. So 11 divided by 11 is 1. 22 divided by 11 is 2. But you have to cross it. You're not dividing by 2. You're crossing when you're getting 2. And you're getting 1. Right? Okay. We're still not there yet. Okay, so here's a suggestion. 11 and 22. 11 divided by 11 is 1. 22 divided by 11 is 2. So notice that I write the answer. I don't write what I divide by. So 11 divided by 11 is 1. 22 divided by 11 is 2. Now I look at 36 and 12. You can do it step by step, but divide 12 by 12 and I get 1. And 36 by 12 and I get 3. What is left? 3 and 2 at the top and 1 and 1 at the bottom. But don't forget, we are multiplying. So 3 times 2, 1 times 1. So the answer is 6. Yes. Are we okay? So now, if I were a student in this class who would say, I haven't done this in a long time, or I don't remember, or it takes me a while, I will make myself a note on the side of my notebook. I do not remember. Blah, blah, blah. I will practice. And box it in, and that's my reminder. I don't remember how to add or how to multiply fractions. And 1 example is not enough. 2 examples are not enough. I need to find 10 more. Okay? So, can we move on?
Yes.
Okay. Now, I would like to talk about division of fractions. So, we chose 7 over 8 divided by 21 over 32. 2 things here. You cannot simplify across in a division like we did with the product. So even if this and this have something in common, I'm not going to be allowed to simplify. We're not allowed to simplify across in a division. Okay, so next, how do I divide 2 fractions? I copy the first fraction and I multiply it by the multiplicative inverse or the reciprocal of the other. So now I'm allowed to, or I have to apply the procedure that we just looked at, AD divided by BC. So please watch all this after when you get the chance, okay?
I will. Thank you.
Thank you. So one remark that I have to make here, and you have to remember this. Have we talked about the least common denominator when we multiplied fractions? No. There is never a need to find the least common denominator when we multiply or divide fractions. The least common denominator is mandatory when we add and subtract fractions that have not the same, unlike denominators. That is a must.
Can you say that again?
Yes. When we multiply and divide fractions, it's easy. I don't have to do anything other than simplify and multiply. But when I add and subtract fractions that do not have the same denominator, then I have to find the least common denominator. Because I've seen it, and I think one of the students even said that. I apologize if I misunderstood. Said, okay, let's find the least common denominator of these two. No. There is no need when we multiply and divide. So please keep that in mind and don't make that mistake, okay? Perfect. So now I'm back to my division here, and what do? I could start by simplifying each fraction by itself. 7 and 8, nothing in common. 21 is only 3 times 7, and 32 is 2 times 2 times 2 times 2 times 2, 5 times. So nothing in common. I cannot simplify this, I cannot simplify this. I copy the first fraction. I change the division into a product. That's not enough. I have one more step, which is 32 over 21. The only chance I have is to simplify across. Do not just get a huge number multiplying the tops and a huge number multiplying the bottoms and then start wondering, okay, what do I do now? It's easier to simplify smaller numbers than get a huge thing that, okay. So,
I thought you said you couldn't multiply across with division.
you have,
I mean, sorry, simplify it going across with division.
but this is no longer a division.
Oh, because you turned it into a multiplication.
That's the rule.
I got you.
Once I turn it into a product, then I'm allowed to.
Okay.
Because now I'm back to this rule.
Also, when it comes to crossing, you have to do it across both sides. You can't just cross one way.
Cross something from the top and the same thing from the bottom. So if you divide the numerator or any portion of the numerator by 5, you have to do the same thing in the bottom. You cannot simplify top and top. So I simplify the top of this fraction by 2 and the top of this fraction by 2. That's not.
Right, I guess what I'm saying is in this example here, regardless of whether or not they're actually divisible, could I only simplify going across from 7 to 32 and not 21 to 8? Or do I have to, does it literally have to form an X? Or can I just go
No.
one way?
For example, what if you had here 11 and 32? You cannot simplify 11 and 32. You would only simplify 7 and 21.
So you can only just go one way. It doesn't have to form an X.
As
That's
long
really
as-
what I'm asking.
No, I'm just saying, but when I show the X, I mean not this with this,
I understand that.
but this with this, or this with this,
Right,
or this with this,
right.
or this with this.
Okay, so, okay. You answered my question. Thank you.
My pleasure. Okay, so then we are doing this. 7 divided by 7 is 1. 21 divided by 7 is 8 divided by 8 is 1. 32 divided by 8 is 4. What is left at the top?
4 over 3.
Yes, 1 times 4 and 1 times 3. Now, if you do not write the 1, you may think it's a 0. And you may get a totally different thing. So please be very careful. I recommend using the 1. When it's 1, 1. 7 divided by 7 is 1. If you don't write anything, you may say, oh, 0 times 4 is 0. Or whatever else. Okay, so let's work on another. Let's say 5. This is problem 27 on page 72. 5 divided by 1/3. have a class at 11, or can you spend a few minutes with me? So we can talk about what you missed. Okay, awesome. It's on your name, sorry. Great. How we doing? Awesome. How we doing? Awesome. Awesome. Now I'm counting in a different way now. In the opposite way. Yes, awesome. How we doing? You haven't changed it into a product. Awesome. When we change 1/3 into a product, it becomes, what is the multiplicative inverse of 1/3? 3/1. Awesome. Awesome. Good. So let's look at adding and subtracting fractions. But I still recommend make yourself a little note on the side saying, I still need to practice. Okay? So any number can be written as that number over 1. Even 0. 0 can be written as 0/1. So that's what you did. And then you changed this into a product. So you wrote 3/1. And then you multiplied 5 and 3. 15/1 is 15. Since we are here, I'd like to ask you a quick question. How much is 15 divided by 1?
15.
Okay. How much is 0 divided by 1?
0.
Awesome. Final question. How much is 0 divided by 15?
0.
0.
Would it be a negative?
Okay. No, that's fine. 0. I meant to write 15/0. How much is 15/0? I'm sorry, that's what I meant. But then you were right. This is 0/15 is 0. How much is 15/0?
0.
Cannot be. If 0/15 is 0, 15/0 cannot be. Cannot.
Undefined.
This is a fancy word that really means it does not exist. Division by 0 is undefined. So it's your part of your homework to look at all those detailed explanations in those videos, right? Please. So if I have 0 and I want to share it with you, I can divide it by 10 and you'll get nothing. But if you want to divide 15 by 0, that is not a number. You can find a number that represents division 15/0. Okay? So here's a little explanation here. Do I still have? Yes, I do. Okay, here's a little explanation. So is 1/2, think for a second, the same thing with 10/20? Here's my question to you. Is 1/2 the same thing with 10/20?
Yes.
Yes, because how did I get 10/20? What did I do to 1/2?
Multiply by 10.
Top and bottom by 10. Okay, this is a very important mathematical term, and that is proportion. Why is this, first of all, so important? Well, for many reasons this is important, and it's called a proportion. Because only in a proportion, and I'm showing something else now, we can cross multiply. So previously I said simplify across, which is something else that was not a proportion, was a multiplication of two fractions. But now I can multiply across, not simplify. Only in a proportion I can multiply across, like this. Meaning 1 times 20 is, and 2 times 10 is, right. So if you give me a proportion, I'll say, oh, okay, so then this product had left and right has to be the same. This product has to equal this product, only in a proportion. Why am I talking about this? Because I want to show you what happens here. That's why I wanted to give you the background. How I'm getting from this to this, or basically from this to that. So now let's say 15 divided by 0 is a number. Let's say it exists. I'm telling you it's undefined. And you should say, show me. I don't believe this. How come that 0 over 15 is 0 and 15 over 0 it doesn't exist? It doesn't make sense. So let's say it's a number. I don't know the number. So I'm going to call it x. Can I write x over 1?
Yeah.
Exactly in the same way I wrote 5 over 1, 10 over 1, right? So it's a number. I want to show, I want to find this number. If it exists, I should be able to find it. If it doesn't exist, then I'll say, well, it doesn't exist. So is this a proportion?
Yeah.
What am I allowed to do in a proportion? So the left-hand side, 15 times 1 is, and 0 times x is,
X. No, 0.
so now I tell you that 15 is 0. What would you say?
That's not possible.
Right. So if this is not possible, then division by 0 does not exist. I can give you a number. And we like to use this word. It's a fancy word describing that it does not exist. Is that clear? So now we can write this general truth. Division by 0 is, thank you. So please keep that in mind. It's very important. Okay, now I would like to look at adding and subtracting fractions. Okay, I'm going to start with an example with the same denominator. I can find one in the book, so I'm not going to waste my time, your time. So 2/3 minus 4/3. And after that, I'd like to look at problem 23 on page 72. And that is 7 divided by 15 plus 5 divided by 6. Let's see how we do this. 1 minute.
Which one are we solving? The first one or the second one?
No, the first one first. Okay, I'm watching. Awesome. We're doing the first one first. 2/3 minus 4/3.
Sorry.
What are we doing? Nope.
This might not be right.
Okay. Awesome. Awesome. How are we doing? Aha. Good. So let's take a look. The two fractions have the same denominator. I'm going to write a long fraction line. I'm going to copy the least common denominator, which is the same one. And then I'm going to perform this operation that I'm going to write 2 minus 4 at the top. Then I perform the operation 2 minus 4. And the answer is -2. So this is negative 2 divided by 3. When I divide a negative by a positive, the answer is? Good. I have to write this. This is the correct answer. Okay, before we look at this one, since we had difficulties with the first one, let's do this now. You need more paper here?
Maybe.
Will you have a notebook next time?
I absolutely will. Thank you.
And I'm expecting to see the notes from the lecture notes in your notebook. So when you watch the videos and transfer the information onto your notebook, I need to see that, please. It's in your own benefit to do this. Just write it first, like we did it. Write it like this, so you don't omit anything, you don't change it exactly. And now, step by step, no, the fraction line has to be, the equal symbol has to be exactly where the fraction line is, exactly pretty similar where you put this one, not at the top. So right here in the middle, exactly. And so you can add the positives. This is what I would do. 7 plus 1 is 8 minus 3. So I added the two positives, and then I subtracted 3. Okay, ready here? So all three fractions have the same denominator. I will copy the denominator, and then I will write what I see at the top. 1 minus 3 plus 7. Are we okay so far? When it comes to adding and subtracting numbers, the order is not important. I choose the order. So I would like to add the two positive numbers first, and I'm going to say 1 plus 7 is 8, and then I'm going to subtract 3. So the answer is 5/2. Please note one thing. The fraction line is here, the equal symbol is here, then the fraction line and the equal symbol in the middle. Please do not show something like this. So the equal symbol has to follow the fraction line. The fraction line has to be right in the middle. Okay? So please be as organized as possible.
This is how I did mine. So I found this first, the subtraction before I added the.
You can, but that will mess us up when we go to the next one with finding the least common denominator. I recommend this method, but again, I accept any method. Okay. Are we okay now?
I had a question.
Yes.
So, you said the top part, it doesn't matter whether you subtract or
The
add
order.
first?
No, it does not.
So no matter what you do, you'll always come to 5?
Correct. So 1 minus 3 is -2. -2 plus 7 is 5. 7 minus 3 is 4. 4 plus 1 is 5.
Well, but I did 3 plus 7, so I got 10.
You can't do 3 plus 7. You have to take 3 with a sign in front. You are changing -3 to +3. You can't do that.
Oh, okay.
The order of the numbers is the one you like, but you can change a -3 into a +3.
Okay, that's.
I could not say, oh, I owe you $1,000. What if you owe me $1,000? I can't change the minus 1,000 into a positive 1,000, even
Right.
if I wanted to.
Okay.
So when it's a very good question actually. So this symbol goes with the numerator. First of all, only with that numerator, not with this one or any other numerator. So the negative sign goes with the numerator of the fraction in front of which it sits. It does not go to the denominator. And it cannot go to both. Because if you transfer it to both, it's going to be a positive fraction. Minus over minus is positive. So careful. So now, -3 is this number. And you cannot separate the negative from the number. Is that clear? But you can arrange the numbers the way you like. You cannot do that in the multiplication and division. But you can do it in addition and subtraction. Okay? Good. Next, I'm going to move on to this. Are we okay with adding and subtracting fractions that have the same denominator? Okay. Now this is the real thing. 7 divided by 15 plus 5 divided by 6. These two fractions do not have the same denominator. Agreed? Okay. So, let's take 15 aside. Okay. I need the prime numbers of 15. Awesome. 3 times 5. 6. I need the prime numbers, prime factors of 6. Very good. Now the LCD. LCD stands for the least common denominator. Least common denominator. Okay. The least common denominator must have all different prime factors I see here. How many different prime numbers I see there? 4. One more time. How many different prime numbers I see?
Wait, prime numbers are 3, 5.
In this green box, how many different prime numbers I see?
4, 3.
3 different prime numbers. All of them have to be in the least common denominator. Now I have to talk about their exponents. What is the exponent of 2?
Yes.
Or the power. Good. What is the power of 3? What is the power of 3? What is the power of 5? 1. What is the highest power that 2 has in the green box? 1. So then 2 has to stay with power 1. What is the largest power? Not the sum of the powers. What is the largest power that 3 has in the box?
1.
So it has to stay with power 1. What is the largest power that 5 has in the box?
1.
So it has to stay with power 1. Therefore, the least common denominator would be now in a product and nothing else. I can do the same thing I did with addition and subtraction. I dictate the order. I can say 2 times 5 is 10, 10 times 3 is 30. Or I can say 2 times 3 is 6, times 5 is 30. Or 5 times 3 is 15, times 2 is 30. I decide. But as long as it's only product. If I have a division in there, I can do it. So this is 30. Okay, ready? So we found the least common denominator. Like before, I write a long fraction line. What do I write underneath now?
30.
Awesome. And now I have one intermediate step that I did not have before. And if I write 7 plus 5 at the top, that would be wrong. So I'm going to write it and say it's wrong. 7 plus 5. Not correct. So then, here's how I proceed. I ask myself, the original fraction had denominator 15. What did I do to it to get 30?
Multiply it by 2.
But if I multiply the denominator of a fraction by 2, what do I have to do to the numerator of that fraction?
The same thing.
Exactly how we simplify. We took 7 away from the top and we divided the top by 7 and we divided bottom by 7. But if I multiply the bottom by 7, I have to multiply the top by 7. Here from 15, I multiplied it by 2. I make myself a note. Hey, don't forget you selected or you chose or you multiply the denominator by 2. Make sure you multiply the numerator by 2. Okay, 6. 6 was multiplied by?
5.
Good. So what do I have to multiply the numerator of this fraction by?
5.
Awesome. So now I would like you to dictate what should I write here as the intermediate step. Don't calculate anything just yet. 14 plus 25. Do we all agree with this? So if we decide to multiply the denominator by 2, we have to multiply the numerator by 2. So basically the new fraction is 14 over 30. And this new fraction is? So that's why we have 14 plus 25. Now here's a question. Don't write anything. Obviously it's going to be wrong, right? I want to do this now. I want to simplify 25 by 5. 25 by 5 and I get 5. And 30 by 5 and I get 6.
No,
Why not?
because the denominator you can
Nope,
really.
not because of that. You're correct.
14's not divisible by 5?
Nope. You have something though. You have something. It's not a factor, yes. That's the idea. So, this is the same with this. Will I simplify something inside of parentheses by 5 and this outside of parentheses by 5? This is a different way of writing this. Since I cannot do it here, I cannot do it here. Bottom line, the explanation is these two numbers are called terms. We cannot simplify terms with something outside like this. A term, a piece of a term, but yes, your colleague was right. Christopher was right. If these two numbers were multiplied, like we just multiplied fractions, yes, I would have been allowed to do this now. 25 by 5 and 30 by 5. But since these two are added or subtracted, they are called terms. We can only simplify factors. These two, 14 and 25, are factors. Factors are quantities that are multiplied. Terms are quantities that are added or subtracted. With terms, we are very limited. We can only combine them if they are like terms, but we cannot simplify. Awesome, thank you.
Out of curiosity, is division factors as well too? Or?
As long as once you change it into a product, they become factors.
Yeah, that's true. Okay.
Yeah. So the numerator, please. The denominator is 30. The numerator is?
39.
Awesome. Now, I'm looking at 39 and 30 and I realize what? They can be simplified.
3,
Yes. 39 divided by 3 is?
13,
30 divided by 3 is? Simplified form of this fraction.
13%.
Awesome. How are we doing? Make yourself a note. I don't know this. I need to practice. Okay, ready for another problem? Do we need another problem like this, or can we move on? Okay. Okay, I can find readily something there. I'm going to make it up. So let's take a look. Okay, let's work on this for a minute. Kirsten. I didn't see Kirsten. Shelby was here. Whitney is here. Keontae is here. Ruby,
Yes.
of course. Corey is here. Melissa. Javi is not. Nicole and Chris. Okay. So I said I have to take attendance every time. Ready? Ready? Okay. So I take 12 aside. I have to present it in prime factorization. What is the prime factorization of 12? So prime factorization. 12. It's a number that is an even number, so it must be divisible by 2. When I divide 12 by 2, I get 6. 6 is an even number. It must be divisible by 2. When I divide 6 by 2, I get, and now these are all prime numbers. So 12 is 2 squared multiplied by the ends. Okay, 27. It's not an even number, so I go to the next prime number, which is 3. Let's see if 27 is divisible by 3. It is. So then the answer is 9. Now I know 9 is divisible by 3, and what is left? 3. So the ends are all prime numbers. So then 27 is 3 to the third. So I have 12, which is 2 squared times 3, and 27, which is 3 to the third. Now I try to find the LCD. So now, how many different factors I see in that pink, orange box? How many?
3.
How many different prime factors I see?
2.
2. So I only see 2 and I only see 3. Now I have to discuss their exponents. What is the largest power that 2 has in any of those numbers? So what is the power that I will have to have in the least common denominator?
2.
What is the largest power that 3 has in any of those 2 numbers? So the power of 3 in the least common denominator will be? Good. So now I know that this is 2 squared, which is 4. I know that 3 to the third is 27. And then I will multiply. 4 times 7, 28. 8 and I carry 2, 108. So the LCD, so I will continue here. I write a long fraction line. What is the LCD? Good. I call these adjustments. What is the adjustment need for the top of the first? And what is the adjustment needed for the top of the second? And the question is, I'll figure it out by asking myself, 12 was multiplied by to get 108.
Nine.
Exactly. So then I have to multiply the top by 9. 27. See, it's right here. 27 was multiplied by what to get 108? So that is exactly what the numerator of the second fraction needs. So now can anyone give us the numerator of this fraction?
5.
Yes. 9 minus 4, which is indeed 5 over 108. This is the procedure of adding or subtracting fractions with unlike denominators. Are we okay? Say it again.
I want to write it.
Sure. So don't forget to write yourself a note right here next to it. I have no clue. I need to work on this. And if I don't work on this now, I will fall behind. I will always try to catch up. I need this now, today. Can we move on to the order of operations? Yes?
Yes.
Okay. So the reason why I write these things is because, you know, sometimes we forget. So you don't have to write this. This is what I would write to myself if I were a student in this class and not being comfortable with adding and subtracting fractions with unlike denominator. Just a reminder that I need to do this and I need to do it now so I can move on. So it's nothing, don't take it personally or anything like that. I'm just, happy that you're here and happy to work with you, but I want us to make progress and make headway. Okay, order of operations. Now, the highest power is exponent, and then multiplication, division, and then addition and subtraction, right? We know that, yes? Mm-hmm. So power first, multiply, divide, add, and subtract. However, I have to say that as I showed, addition and subtraction, you decide the order. But when it comes to multiplication and division, you can't decide the order. So for example, if I have 2 multiplied by 3 and divided by 6, you have to perform the operations from left to right. Okay, you can't say, okay, let me divide 3 by 6, I get 1/2, and I multiply by 2, blah, blah, blah. You can't do that. So from left to right means 2 times 3 is 6, and 6 divided by 6 will be 1. Now what happens when grouping symbols are involved? Grouping symbols. We have 3 different types of grouping symbols. And there is one that I need specifically to say it's not a grouping symbol. This one. Not a grouping symbol.
Is that an absolute?
Exactly. Absolute value. So let's say x. The absolute value of 3 is the number of units from 0 to 3, 3. The absolute value of -7 is the number of units, the distance between 0 and -3, and the distance is? Yes. The distance is always positive. Good. So now what are grouping symbols? So we have 3 different grouping symbols. This one is one. This is the second one. And this is the third one. This has the first priority, this has the second priority, and this has the third priority. If they're all involved in an expression, I have to clear the parentheses first. Parentheses, brackets, braces. If all 3 are involved in an expression, I have to clear this first. Then I have to clear secondly, brackets and braces. So I'm on page 74. There are no examples with brackets here or braces, but I will give you an example since I mentioned them. So let's look at problem 124 on 74. -15 plus -4 squared plus the absolute value of -9 everything over 10 minus 2 times 5. Okay, here's a question for you. Can I simplify? I would like to simplify this 15 with this 5. I want to cross out 15 with 5 and say 15 divided by 5 is 3 and 5 divided by 5 is 1.
Yeah.
Right?
Yes.
Gotcha. So 15 is a term. It's connected by addition to other terms. 5 is connected to 2 as a product, but this quantity is a term in the denominator. I'm not allowed to simplify terms. Clear? Okay. So now I have the numerator to work on in order of operations and the denominator to work on in order of operations. I cannot do anything to negative 15 as of now. I got to plus, and I'm asked to, because I have to start with exponents, so I have to square negative 4. What do I get?
Negative 16.
So first of all, I am squaring a negative number. Negative 4 times negative 4, I need the sign first.
Positive 16.
Positive 16. Do you all agree with that? When I square a negative number, I always get a positive number. When I square anything, I always get positive. Okay, now I find myself in front of the absolute value of negative 9. What did we just talk about? What is the absolute value of negative 9?
Positive 9.
Right. So positive 9. So that's the numerator as of now. Now, the denominator, I copy 10, so I can't do anything to it. And here I have at least 2 options. Here are the options. 2 times 5 with minus in front. One option. Second option. Negative 2 times 5. I personally prefer this. 2 times 5 with minus in front. What is it?
Minus 10.
Let's go back to the top. Remember, I'm down to addition and subtraction. I dictate. I do what I want. So here's what I want to do. I want to do 16 minus 15. 16 minus 15 is,
Negative 1.
careful, 16 minus 15 is,
16 minus, oh,
right, 1 plus 9 is
10.
10. And the denominator is,
0.
okay, what do we conclude?
10.
75.
Oh, it's on.
Gotcha,
Oh my god.
gotcha. Okay. See, that's why I write on paper. I could have not done this with a board, right? So now with paper, I can say, look, please pay attention. Okay, so the answer is undefined. I'm okay if you say I don't like the word undefined. I'm going to write it does not exist. I'm fine with that too. Whatever you want. Okay, ready? 72. Now this is your baby. And I'm watching you like a hawk. Here it is. 72. On 74. 11 minus negative 9. This is in parentheses. Plus 6. In parentheses. 8 minus 2. And everything divided by 2 plus 3 times 4. 1 minute. negative in front of negative, it's like -1 times -9, or the opposite of -9. We have to perform the operation in parentheses and then multiply by 6. I don't recommend you distribute 6. You're not multiplying. 11 minus, in parentheses, -9, that's not a product. Two plus 12 is? I think so. How are we doing? We're doing well. But what happened here? How much is 2 plus 12? How are we doing? The opposite of -9 is +9. Correct. And in parentheses, 8 minus 2 is 6. Yes. Okay. Good. So the opposite of -9 is 9. No, the opposite of -9 is 9. 11 plus 9. So it's 20. And yeah, the rest is good. Okay, not too bad. This was good. Okay, so let's work on this together. So 11, this is a very important process. This is like -1 multiplied by -9, which will give you 9. Or you say the opposite of -9. One or the other. You either say -1 times -9, or you say the opposite. The opposite of -9. -9 is here. The opposite is 9.
I have a question.
Yes.
There's always a -1 before
Yes.
before every
Yes.
parenthesis.
Yes.
Right?
If there is a negative in here, there is
There's
a
a
negative
one.
1. If it's positive, there is a positive 1. So then 11 plus 9 and plus this, as you wrote, is indeed 6. I have to perform the operations in parentheses. Now, if you want to write it, you can write it with parentheses or you can write it like this. But you cannot write it without parentheses or without a raised dot. One or the other. Because otherwise it will look like 66. So, yes.
The mistake I did was subtract 8 minus 2 and then add it, not multiply.
So if there is no symbol here, it's multiplication. And we have to make sure that we are not changing anything, any portion of or any part of the problem, right? We can't change what we're given to work on. Okay. So then the denominator is 2 plus, indeed. I did not see a 5 times 4, which is awesome. Of course you cannot do that because you have to give priority to the product first, right? So you all copy the 2 and you multiply it and you get 12. So this is 20. Yes, you can say, wait a minute. You just told us to do the multiplication first. True. So 11 plus 9 plus 36 divided by 2 plus 12. I can perform here. Now here's a question for you. I want to simplify 36 and 14 by 2 before I add.
Can't do terms.
Thank you. Good. So this is 11 plus 9 is 20. 20 plus is, right, 56 divided by 14. And then 56 is an even number, 14 is an even number, so I am going to try to simplify. So 56 divided by 2 is 28. 14 divided by 2 is 7. Okay, now I already see 28 divided by 7 is
4.
Okay? How are we doing with this?
Okay. So
Do we need another, or is this good enough?
another one more.
Say again?
Another one more.
Okay. 46 on 73. So 5, bracket 3, parenthesis 2 plus 5 minus 5, and close the bracket. I know we only have 8 minutes left. I would like to talk about evaluating algebraic expressions. These 3 major topics we have now: fractions, order of operations, and evaluating algebraic expressions. Okay, 1 minute on this. Watching you. Okay. But I am watching. Okay, allow me to work on this problem slowly so you can follow and understand. And I don't know if you made mistakes or not. I really didn't see anything yet. Okay, so if you remember, this has the first priority parentheses, a set of parentheses, and the second priority brackets. So obviously I have to start here. I perform that operation and I get a 7. And obviously this is a multiplication. I copy everything else without touching or changing anything, in other words. So this is definitely multiplied. I don't see any symbol. So this is a bracket and 3, and I have multiplied by 2 plus 5, which is 7, and then minus 5. I eliminated parentheses, and now I have brackets to deal with, but inside brackets I have to apply the order of operations, which means I have to multiply first. So this is 5. 3 times 7 is 21. 21, and I copy 5. 21 minus 5 is 16. I know that this is a product, so this is 5 multiplied by 16. So I eliminated brackets now. 21 minus 5 is 16. So now I multiply 5 by 16. And I get 80. And this is the final answer.
I did a different way and I still got that.
I'm not sure about the different way. You have to be careful.
So I did 5, 3, 7.
Yeah, we did the same thing.
Oh.
Yeah, everything the same. Very good. So last thing, I know I have 5 minutes left. I would like to talk about evaluating algebraic expressions. So let's say I have 2x squared y cubed minus 4xy. This is an algebraic expression. It has numbers, it has operations, it has variables. It's an algebraic expression. I would like us to evaluate it for x equals negative 2 and y equals 2. What does that mean? It means that I have to exactly. So that's the first step. I have to replace each and every variable by the given value, by its given value, and I cannot change anything. Everything has to be in parentheses, especially if it's a negative number. With positive numbers, you can get away without parentheses. And I have to mimic everything I see without dropping any powers, without changing the operation symbols into something else, step by step. I copy the 2. I have x, but x is a negative number, and that negative number has to be raised to the second power, multiplied by, I can get away with no parentheses now because 2 is positive and raised to the third power. So this is only replacing x and y with the given values in this expression. I reached -4. I have to copy -4. And then I have x to copy, which is -2. I have no choice but put it in parentheses because it's a negative number. And then y multiplied by 2. If you feel comfortable to put parentheses, put parentheses. I don't recommend too many parentheses because then you may lose track of what's happening there. So don't correct something that works. But look at my method and say, this seems easier. Or it makes more sense. Or say, it's okay, but I still want to stick with my method. It's fine. Now, by the order of operations, what do I have to perform first? Yes, the parentheses. So I have to perform this first. How much is -2 squared? Anything squared, you cannot give me a negative number. Yeah, so it will be 2 times 4 times 2 to the third. Now I reach this product, and I can do this. -4 times -2. How much?
Positive.
Positive 8. Positive 8 times 2.
16.
That's it. Could everyone follow here? Or should I do this again? Were you able to follow this? Yes? Okay. So now I have to change this into 8. So 2 times 4 times 8 plus 16. And now again I can do whatever I want in the product, but only the product itself, right? 2 times 4 is 8. 8 times 8 is 64. Or 8 times 2 is 16. 16 times 4 is 64.